Hey guys, are we live? Just let me know in the chat section if we are live, and then we can begin. Just quickly confirm in the chat section if we are live. You can hear me and see my screen. Yeah, it's been a while. Some people are saying it's been a while. Yep, that's true. All right, so looks like we are live. Welcome back, everyone. Now, this is something that we had started, I think, a few weeks back, in which we were going live every now and then, and we were solving LeetCode problems. We are solving more data structures and algorithm problems, and that's what we will be continuing today. So I had been on vacation. Most of you already have seen the pictures on my Instagram about the reason why I was not live for such a long time. But anyways, now we are back and we'll be solving more problems. So before we start solving more data structure and algorithm problems, I would first announce that this is a sponsored live stream. So thanks to 𝗣𝗥𝗢𝗘𝗪 for that. Um, and I'll quickly move on to our sponsors. So 𝗣𝗥𝗢𝗘𝗪, as most of you know, they are a fabulous website for where they have a collection of well-written crafted courses for software developers. They have courses on a bunch of things like React, system design, Java, Python data analysis, scalability, system design, coding interviews. They have a bunch of learning paths that you can just go through. And I really felt that these courses are really good. Why? Because they save a lot of time. They are very well articulated. And the best thing is Educative Unlimited, in which you don't have to purchase these courses once, but you can pay once, and then all these courses are with you forever. So just to make sure that you understand that they already have a 40% discount for India, but you will get additional 10% off if you use the coupon Rachit, or if you go to educated.io/Rachit. So the link is on the screen. You can see that, and then so you'll get additional 40% off plus extra 10% off, and then the good thing about them is like they have inbuilt workspaces widgets. As you can see, you can write code over here, and you don't have to like do the setup thing. Uh, it's very well articulated so that you're learning, you can see everything on the left side and you can write code and move forward. Similarly, for React courses as well, they have full-fledged integrated workspaces. You get a VS Code kind of editor in which you can create files, run code, and see the output. So if you want to enjoy or have a look, go to educated.io/Rachit. And now let's move on to problem solving. All right. Again, before I share the link of the problems, you can join the Discord. This is where we'll be pasting the link to the problems. And now let's see, what do you want to solve? Let me know in chat if you want to solve any particular tag, DP, or probably trees, or probably linked lists. Let me know in chat section. Okay, so few people are saying trees, some people are saying DP, some are saying graphs. On the chat, please don't spam. Okay, I think a bunch of people are saying trees. So actually, let's go and solve few tree problems. All right. Uh, I think LeetCode has changed a bit from the last time when we were here. We used to have over here, now we have companies. All right, that's fine. Where are the tags? Okay. So you want trees, I think. Binary tree, everything, right? Yep, that should work. Let's sort on based of difficulty. Okay. Okay, so they have implemented different kind of sort. This is like random. This is, why is this medium coming first? I don't know. Okay, let's see. Bunch of things have changed, so bear with me for a moment. Um, let's solve something like path sum and invert a binary tree. I Let's do this as well. I think this will be good if you want to understand recursion. Uh, what else? Okay, let's quickly move to the problems and solve these first. So this is saying that given the root of a binary tree and an integer target sum, return true if tree has root to leaf path such that adding up all the values along the path equals the target sum. A leaf is a node with no children, that we know. So this is the tree and the target sum is 22 and the output for that is true, and they have highlighted in blue color, I think, that 5 plus 4 is 9 plus 11 is 20 plus 2 is 22. So if you have some path from the root to the leaf which is having this particular target sum, you have to return true. So essentially what you can do is you can use recursion, and when you are going to the next node, you can add the sum of the current node up to current node. Sorry, not just the sum of current node, but the sum up to the current node from the root to the next node. So in this way, you can store for every node when you are doing the recursion or DFS traversal. At each point of time, you already know the sum from the root till that particular point. So in this fashion, you can go and on. You can continue doing this until you reach a leaf node, at which point you can check if uh, the current value matches the target sum. So just, I think the pseudocode will make it more clear. And before like I do anything, let me just paste this problem one over here. All right. So what I'm trying to say is we'll do DFS, and we can do return DFS from root. The target sum is this, and this DFS will take care of that thing. All right. Or we can use this hash path sum itself. Let me think. And actually, let's also pass 0. And now we can have current. So the current node that I am at, the sum from root up to the current node. So sum from root and then in target sum. All right. So this is what we have to do in this particular problem. Okay. Actually, this can be a private member. So let's actually move this to something in target. And then over here, we can do this target sum is target sum. And then I can make my DFS function a bit clear with 2 arguments. Okay. Now what you can say is when you are going to the left child, you can say cur left, and then the sum from root will be as it is, plus the current value gets added when you do the recursion. I hope that makes sense. And current sum is nothing but this particular thing. And if current sum is target sum, you can return true. All right. If going left gives you the target sum, then you can actually return from there. Or if that does not return, you can go right. So if either of them return true, then you return true, else you return false. So we have not handled the base cases, but what I'm trying to do essentially is using recursion over here. And the idea is basically sum from root is giving me the sum from root up to the parent of my current node. So the current sum becomes the sum from root. This is having the sum up to parent from starting from the root. And then I add the current value. So this gives me current sum. And if this is the target sum return true, this is wrong because you also have to check if this is the leaf node or not. So if current sum is target sum, you can actually have something over here because I think all the values are positive. And if this is not a leaf node, then we do not need to go any down further because that will only increase our sum. So if it's leaf node, then return true. If leaf node, return true, else return false. No point of wasting more time. It's already, I think this, okay, so the node values are negative as well. So you can't do return false over here. That should not be the case. So if current sum is this and it's a leaf, so how do you check if it's a leaf? We will come to that later. But only if it's a leaf, you return true. Otherwise, you continue going down and down further. So how do you check if uh, something is basically a leaf node? You can check if the left and right are null. So this is null, and so this is the condition for is leaf. So bool is leaf is nothing but this. And then over here, now our code is completed. Um, we have not handled base cases. That's one bad thing. Actually, it should be the other way around. So you can say if is leaf, then you can actually return this. Now it's much simpler. So if it's a leaf node, we check if the current sum and target sum match. If they do, we return true. Otherwise, we return false. Otherwise, if it's not a leaf node, then we know that we have the left and right childs. And over here, it might happen that the right child is null. So in that case, we should return false, right? And if, yeah, so that's one other thing. So if cur itself is null, you always return false. This is another base case that was missing. We have added it. Otherwise, if current is not null, we can calculate this thing. So this can go down over here, and this looks much better. So you're checking if it's leaf node, we calculate the current sum. If it's leaf node, we do this. Otherwise, we check if we can make the target sum from going left or right. And now this should work. All right. So I think we have handled a lot of edge cases as well. So let's see if this, first of all, compiles. So it does compile. Let me submit this. And it's working fine. Cool. Anyone, any doubts in this one? We can talk about the time and space complexity. Otherwise, if anyone is having any doubts, just let me know in the chat section. Anyone, any doubts so far? I think we can move on to the next problem. There is a bit delay, so that's why I'm just waiting few more seconds before we move to the next problem. What about the likes? I think we have very few likes and the viewers are very high. So if you are still watching and enjoying the stream, make sure to hit the like button and increase the like count so that even more people get notified about the stream. Line 23, someone is asking that they are having doubt on line 23. So actually we can make this a bit, actually this is much more simpler now, and I think this will still work. I missed the semicolon. So what we are doing over here is nothing but, I did add, okay, one extra bracket. So what we are doing over here is we are saying that, okay, we were not able to make the target sum right now. We haven't reached the leaf node yet. So we are going on the left and right child. However, we are using double OR operator. What it does is if when you are going left and somehow we make the target sum by from the left subtree, we straight away return true. We do not do the recursion towards the right. If you use once OR operator, it will still work. However, the time will increase. So right now the runtime was 8 milliseconds. And if I submit again, this will still work. But okay, so this is weird. But it should have been greater than the previous count. This is like, I think the timing is so small or the test cases are not that good, but you can construct such a test case in which this will always be much more optimized. All right. So the time and space complexity, I think, I think the time and space complexity is important over here. A lot of people will think the space complexity for this is order one because we are not using any array. However, we are using recursion and you do use stack space. Recursion uses stack space. And the worst case time space complexity can be uh, order height of this binary tree, right? And if the binary tree is skewed binary trees are nothing but um, it's kind of like array. So skewed binary tree is nothing but you have one node here, then the next node is like this, and the next node is, so there is no branching. You basically just make an array. So these are skewed trees. So if you have something like this, the space complexity can be order n in that case. If you someone is spamming the chat, let me remove that user. So space complexity in worst case can be order n. Time complexity is again order n because of the TFS. All right. Let's move to another problem. And if you are asking where the problem is, you can see the chat section. The pinned message is already having the Discord link, which is this. Over here, we paste the problems so that you can also. Okay, invert binary tree. I think this is like very famous in computer science. So let's solve this real fast. What it is saying is you're given a binary tree and you have to flip this, right? So 4, 2, 7, 1, 3. So everything is flipped. The 7 comes over here, and then 7 itself is flipped. We have 9 and 6 over here, 3 and 1. So you have to do this. You can think of it as drawing a mirror or basically just taking it and rotating it from the root in vertical axis. Okay. So how do you handle such questions? And I think the best thing is because we are doing trees, a lot of you will actually be better with recursion after this. Because binary trees questions, I have seen, like even when I was practicing binary trees, I actually improved a lot in terms of recursion. I developed that mindset of how to think uh, about recursive functions and how to implement them, right? Because they are functions which are calling themselves. So it might get a bit tricky if you do not get that taste, but I would say recursion is an acquired taste. So, like you continue doing practice more and more recursion, and you will be better at it. So in this case, you will see if you have to invert the binary tree starting from 4, you can see that it's actually same problem on the subtree 769 as well as on the subtree 2, 3, and 1, right? So you do have to invert 2, 3, 1 subtree. You have to invert the subtree starting from 7. And once you do the inversion for them, you can actually change the left and right pointers of the current node. Okay. So step 1 is invert the child subtrees, and step 2 is flip the pointers for left and child of current node, right? If you do this, I think the problem is solved. So invert the child subtrees, how do we do that? Well, we can do something like tree node star left is invert tree root left. Similarly, you can invert the right using this recursive function. So I've done the step 1. Now I just have to flip the pointer. So what I can do is root left is right, and then I can say root right is left, and then I can return root. Now what are the base cases? If root is null, return null. That's one thing. What else do we have? I think that's pretty much about it. About the problem link, I'm pasting it in our Discord. Let me quickly do that. So I think this makes sense. We have done the inversion, we have done the flipping. Let me just run and see if it's working. And it works. So it might have been like, it might be looking like really complicated. How do you do this? And recursion beautifully solves that thing. Shivam is wishing me congratulations for the marriage. Thanks, Shivam. Right. Anyone, any doubts in this one? Let's move on to the problem. Let's pick some medium problem probably. So difficulty, can we? Okay, so difficulty medium. Uh, so what is this status? Unique binary search trees 2. Unique binary search trees, validate binary search tree, recover binary search tree. Okay, I think uh, these might be a bit interesting. What is validate binary search tree? Whether the given tree is BSC or not. I think that's pretty much about it. Someone is asking, how can we do this? So first of all, we pick trees, and someone is saying, how can we do this question using Morris traversal? I don't remember Morris traversal. What is Morris traversal? That does not imply the use of recursion or stack. Okay, so is it playing? Oh, so we have, see, such a good website, right? We search Morris traversal and we have Google again sponsoring our web. The sponsor of this video is Educative, and this is another throw for Educative, another shout out. Links are created as successes and rules are introduced. Okay, so basically it's using clever links. So changing pointers in such a fashion that you don't need some recursion or stack. Okay. So I think there will be some while loop and there will be next, 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 something like that. Okay. While loop. Okay. Yep. I'm not sure I would be able to do justice in a public stream to explain this because I have to read it myself first, and I don't think the stream is meant for that. So let's move on to validate BSG. Um, so another doubt. So Samir is asking, how do I build logic very fast? I'm not able to build logic to see solution every time. Uh, so I think it's about how clearly you understand the problem. That's how I'll put it. One thing is just, getting that accepted and moving on. The other thing is clearing your concepts, like not just solving the problem, but then also being prepared for future problems that come based on the same problem or the same genre. Okay. If they have the same principle involved, you should be able to solve the new problems. And can you do that? Well, if you are solving problems on trees, binary trees, for example, then you should, for a given principle, like DFS or let's say pre-order traversal or in-order traversal, you should solve more and more problems and try to understand what is the application of that particular principle. And, not just like remember the problem and how you solve it, but try to understand how actually you are solving it. And could you have thought about this on your own? So spending that time, is going to clear your concepts and also, make sure that you're able to apply those concepts in future problems. So you have to do practice as well as, I think that a lot of people do practice, but they forget the gist that it's not just about solving 10 problems and getting accepted in all of them, but It's also about whether you are understanding things. Okay, cool. Um, okay, so now we have to, I think the function actually makes it very clear that we have to implement this thing is valid BST, and it's having a pointer. So the thing about BST is all the elements in the right subtree are greater than the current number, and all the elements in the left subtree are less than or equal to the current number. And in some cases, the equality is a bit debatable, as in this case, it's saying that in the left subtree, all values should be less than, strictly less than. And then in the right subtree, all values should be strictly greater than. Okay. So I don't think there will be any duplicates in this thing. And we have negative values as well. That's fine. But the thing is, it's not just valid for the root node. Okay. So if you look at a bigger example, for 5, all the elements on the right should be greater than 5. However, in this case, we have 4, right, which is breaking that constraint. However, if it had been, let's say, actually, it's not a good example. Let me draw a good example. So let's say you have this root node as 5, and then we have over here 3, and then we have 7 here, and then probably 2 here, 1 here, something like this. Okay. And then we have 6 and 8. So for 5, if you will compare this thing, all the numbers in the right subtree are 7, 6, 8, which are greater than 5. All the elements in the left are smaller than 5. However, it's still not a BST. Why? Because if you look at 3, the same property should also be applicable over here. So if you will consider the subtree of 3, and the subtree of 3 is nothing but consider 3 as the root node and whatever goes from below that. So you can see that 1 is actually smaller than 3, but it's coming to the right side. Okay. So you have to make sure that this constraint of right and left also is followed in all the nodes and their subtrees. So actually, uh, when is a tree a valid BST? So you have to is valid BST. So the left subtree should be also a valid BST. The roots right should also be a valid BST. And what else do we have? And now we also want to make sure that all the elements in the right side are greater than the current, and all the elements in the left side are smaller than the current number. Okay. So you can find out the min from the right subtree, and if that min from the right subtree is greater than the roots val, you can safely say that all the elements are greater than that. Similarly, you can find the max from the left subtree, and then you can do the comparison that the max should be smaller than 2. So you can do that thing, and I think we should be good to go. So that's one way. Let's actually check how do you do that now, because um, this these two things are always like you need that to happen, and then you also want the constraint to happen. So how do you do that? So let's do a DFS instead, and let's get the min and max both from the subtree, right? Let's get the min and max both from the subtree. So let's say we have a DFS function that returns okay. All right. Do we want to do that? That's what I'm thinking. So coming back, what did I say? I said that these are the basic conditions. Only if this is true, then we'll do something else, right? Actually, let this be a vector. Let's make a struct. Struct node, what does it have? It has min, it has max, and it has bool is BST. And the DFS returns the node. And over here, what can we do? We can call DFS on the left. We can call DFS on the right. Just bear with me for a moment. So what I'm trying to do is, in one particular DFS, I'm trying to get all things, whether it was a BST, what was the min in that subtree, and what was the max. And using these informations, I will try to play around. So this is what I'm trying to do. Okay. Let's have a base constructor. What it does is min is int underscore max. Max is int underscore min, and then is BST. It should be true or false. Let's see. Right now I'm keeping it true. This I will need to check later. And what we can do is node answer. Then if current is null, return answer. Else, how do you find this thing? Okay, you can find the node left by using the DFS on the left. Similarly, the right will be DFS cur right, and using this, you can actually return the answer. How can you do that? Let me tell you. So answer dot min is nothing but min of answer dot min, comma left dot min, and then we have answer dot max is max of answer dot max and left dot max. I think I'm missing something. Right is also there, right? And another thing should be the current candidate. So the min of three things, and I think this is something that you'll enjoy. So in C++, you do not have a min that accepts three arguments. However, if you had been following my GitHub repository, which is modern CPP tricks, you can actually see that we can use. So basically, _val is also there, right? Yeah. So min of three things, we can put them in an initializer list. This is what I have mentioned over here. So you don't need nesting of min of x, min of y, min of z, and k. You can do something like this, and that's what I'm using. All right. Similarly, over here, right dot max, left dot max, and then _val, right? And what about is BST? Well, it will be a BST if I think we don't need this now. We can do something like return DFS root dot is BST. So now over here, if left dot is BST and right dot is BST and yeah, and then we want to do the check of current node. Present current violation, and there is no violation. What is violation? Well, for the current, you can do that the _val. If this is, I think if left dot max is greater than _val, then there is a violation. Or if right dot min is smaller than _val, then that's again a violation. So if we have a violation, this should be false. So there should be no violation. That's what I'm doing. Okay. So this looks cool. Let me run the code. And the base case, yeah, I haven't thought about the base case. So let me think about the base case. What should happen? If I have a leaf node and I'm doing these calls, what should happen? So I think this should not, yeah. So this is fine. This is fine. This should not contribute anything. So when I'm doing, yeah. So this will also not contribute. This thing should also not contribute. So this, yeah, I think this should be true. Yeah. Let's actually submit and see if this works. So we are getting a wrong answer. We have 2, 2, and 2. What would have happened? Let's check that. Okay, so this should be equal to as well. That's my bad. And I think now it will work. Okay. So when we have a single element, the output is false, expected is true. Um, okay. We returned false because I think violation was everything was okay. This is int underscore max. That's the problem. Uh, let's actually change this. I can make this a bit, I can make our lives a bit easier. What I can do is use long int over here. And then instead of int underscore max, I can do plus 10, or let's say into 2, and then int. So I can do I can increase the count now to LL to avoid overflows. So this is just because of overflow, and it's a good edge case that actually we missed. We should not have missed that. This is actually int underscore max, because of which we are calculating the violation incorrectly. So since now I have made this long, I think now we should be able to cover this case. Okay, so it's saying that curve val is okay. So in the initializer list, we are pushing long, and then this is not long. So actually, let's cast that so that the compiler does not complain. Life would have been easier if we were using Python, isn't it? And it's success now. All right. So this is the first time I think I use such an approach. I do remember an easier solution to this, which was about using range, and I will actually mention that. Um, but this is also good. I think this was something that I hadn't tried before today. But yeah, I think this was good implementation, not too long, very small, crisp, and easy, I think. But we have a better solution to this, and that's what we will do now. The better solution is a bit tricky, and I hope you learn something that I'm about to share with you. Okay. So this trick, what it is saying is, imagine like this. On the root node, you have no constraint. It can be from negative infinity to infinity. However, when you are moving left, the constraint on this node now becomes negative infinity to 5, right? Because it should be smaller than 5. And when you move to the right, the constraint for this node becomes 5 to infinity. And then when you move left, the constraint now becomes, now there is a violation over here itself. However, let's say this was 14. And when you move left, the constraint becomes 5 to 14, right? It should be greater than 5 and less than 14. So in this way, as you are going left and right, you make your bounds tighter and tighter. And for every node, you just check whether it's following those bounds. So you don't need any extra space and all those things. So everything will get committed. Just see this now. Let me make this a bit shorter. So we are having this DFS tree, right? Everything will become small. Um, this will become, I'm not able to write. Okay. Is there any lag, guys, in the stream? Let me know if there is any lag. I don't think there is any lag. Okay, the battery is low. Let me plug in the charger. Just give me a moment. All right. So how does the range thing works? Well, you can do DFS. and you can say this is from negative infinity to infinity. All right. So you can say minus infinity to infinity. What is infinity? Well, it can be const um, long int just to handle the edge cases. Infinity, it's nothing but, you can say int underscore max times 2. In the current context, this is a good enough infinity value that we have. And this returns a bool, and it returns cur, it returns the left bound, or you can say x, or small and big. And over here, what you can say is if cur is null, return true. Else you have to return cur val should be greater than small, and cur val should be less than big. So this is the like basic condition. So if this is there, only then you do something, else you return false. Okay, return false here. Or you can negate this. So if you do the negation of this, what would it become? Well, this will become if current val is less than equal to small, and this will become or, and this will become greater than equal to. So now your return false can go over here, and this is a bit more cleaner. Okay, now if you are here, well, the current node is handling those bounds, and now you make the bounds much tighter. What it means is nothing but the small will become min of small comma cur val, and these are long int again. Right. Again, C++ will complain, so let's cast this to long. Similarly, big is nothing but max of, actually this is min and this is max. You have to make bounds tighter and tighter, right? Yeah. And then you can simply say if return DFS of cur left and DFS of cur right, and this will still work. Well, this is much more simpler, right? Hopefully this works. Okay. Yeah, so this is an overflow to LL. This will be better now. Okay. I have to pass in the values. I'm not doing that. Semicolon missing. Let's submit this. So you're getting wrong answer, and why is that? We have 2, 1, and 3. We are returning false. Okay, let's see what's happening. For 2, I think it should have passed, and then let's actually print, or let's have a look once in our code itself. So if current is null, we are returning true. Otherwise, if the current val is less than the smaller value or equal to, and the current value is greater than or equal to the bigger value, then definitely there is a break and there is a violation. So we have to return false. That makes sense. Now I'm making the bounds tighter. What I'm doing is I'm saying that small is max of small or current val, and big is min of big and current val, and then I'm going left and right with my updated constraints. So when I'm going at 1, um, okay, so this is not right. I'm updating the constraints in both, which is not cool. So when you're going to the left, the small will stay the same and big will only get modified. So um, you can say left big, and this is long, right? When you're going to the right side, so what I'm trying to say is when in the problem, when you went to the left, it became negative infinity to 5, right? So this is what I'm doing over here. And over here, what will happen is it should be greater than 5, right? So the small thing will get updated now. So you can say long. right small, and pass in the right small over here, and the big will stay as it is. So this looks better now. Earlier there was a problem in our code, and now it's successful. This is not like really short. We don't need any struct. However, there was a trick, and this is something I hope you keep in mind. This is something which is reused in many else problems based on binary trees, in which you kind of for every node you pass in the range, and based on that you try to decide. So this makes problem a lot easier, right? As you can see, the implementation is much clearer now, but it might be a bit tricky to grasp. So yeah, that's pretty much about it, guys. I think with this, I'll just open the Q&A session, and then probably we can close the live stream for today. I had lots of fun, and I hope uh, this made sense. And like I think we resumed after quite a long time, but I really enjoyed solving the problems that we did today, and I hope that you also kind of solve the problems. I think we have already pasted the problems in the Discord. Yeah, no, this is not mentioned. Let me actually paste this as well. And that's pretty much about it. So guys, any questions, let me know in the chat section. um, any questions, guys? We can probably do this question tomorrow, or probably day after tomorrow, whenever I'll come live. Any questions, guys? And what about, guys, make sure you hit the like button if you are still watching the stream and you have still not hit the like button. Also make sure that you click on the bell icon and the subscribe button, right? Bell icon is important. Otherwise, I'm going live. I'm sorry, I'm not having any schedule right now with me. But yeah, if you want to catch up with me whenever I'm going live, make sure to hit the bell icon. I will actually wait for 10 seconds. Just go and come back. Do hit the bell icon in next 10 seconds. It doesn't take much, right? And these things, I think the creators have to, actually speak to the audience, because sometimes it just skips your mind. So do this, otherwise you will miss whenever I'm going live. So do this. Okay. Okay. We do have a bunch of questions. Let's take them one by one. Is it okay if we use JavaScript to solve these questions? Of course, it's fine. No problem over there. Um, Pranav is having another idea. Let's see that. How about storing the elements in order traversal and checking whether the array is sorted? That does make sense, because for BST, the in order traversal is always sorted. Okay, that is an interesting idea. Yeah, it actually makes the problem much more easier, right? But is it always true for a binary tree if we are doing in order, and if the array is sorted, will it be a BST always? I think it might. I think it might work. Actually, let's do this quickly and see if this works. So what he is saying is do the in order. How does in order work? Let's do that quickly. We can use a vector and result or array. Okay. Over here we can say that array is empty. Then we can say DFS root, and then we can say that if the array is sorted, then we are good to go. So for int x in R, and ref is, or let's do long int underscore. So how do you do the comparison? If x is less than or equal to pref, return false, return true, right? So if the array is sorted, this will never get executed. X will always be greater than pref, and this should be int underscore min start 2l. And after that, pref is nothing but x. All right. What do we do in DFS? Well, if current is null, this is void. We do a return. In order, we don't have to do anything over here. Okay. So let me remove everything. So how in order work is curve left, then you do the push curve val, and then you go DFS curve right. Okay. So everything looks good. Let's actually run this code. This might work. I think this will work. Discord link, someone is asking. It's already pinned in the chat section. Otherwise, it's bit.ly discord hyphen Rachit. It's already pinned in the chat section, so you don't need. Yeah, so this also works. What else do we have? But I think if you do such kind of things, the interviewer might say that we don't like this. You removed all the fun from the problem. Let's make life hard for you. Do it this way, do it that way. People do all such kind of things. Uh, Sahil is having an interesting question. So Pranav, good point. Yeah, this can work. I think I used to do this a lot. I just have been out of touch. But yeah, thanks for the reminder that it's always true. In the reverse also, that if an order is sorted, it's always BSP. At what age software engineers retire? Well, like I don't think I've actually not seen software developers who are like in their 50s or 45, something like. I haven't actually seen such software developers. Probably they move into the manager role or some other role. So yeah, like I think principal software developers. If we'll talk about that, I think uh, I know one. In Microsoft, we have who worked on the distributed storage. He is doing research. Clark something. I forgot the name. Lambert something. Yeah, John Lambert. No, I'm not sure. He's doing research um, in distributed storage. I forgot the name. Yeah, I have forgotten the name, but Leslie Lambert. Maybe, maybe this guy. Yep, yep. Yeah, that's what I'm talking about. I think he is a distinguished software developer in Microsoft, which is like very difficult to attain. What is his age? 80 years. Damn. So yeah, I think few software developers. If you have passion, like this is amazing, man. Huge respect. Amazing. But yeah, what else? Any more questions, or can we end the live stream now? All right, guys. I think that's pretty much about. Okay, guys, that's pretty much about this live stream. I will meet you again in a day or two. Till then, hit like button, hit bell icon, hit subscribe. I hope you have done this. I will actually go and check the YouTube stats and make sure that you guys have done this. If not, again, it's a reminder to do this. And again, thanks educated.io for sponsoring this live stream session. I think it's amazing. And again, guys, you can go to educated.io/budget to enjoy the discount.